Welcome to another episode of Building Better Systems, where we chat with people in industry and academia that work on hard problems around building safer and more reliable software and hardware. My name is Shpat Morina.
And I'm Joey Dodds.
Joey and I work at Galwa, an R&D lab that focuses on high-assurance systems development and broadly hard problems in computer science.
Today we're going to be talking with Steve Weis. Steve's a senior staff security engineer at Databricks, a company that helps people store, visualize, and manipulate data sets. Steve has a wealth of experience in security, cryptography, and software engineering at a wide range of companies, including Google and Facebook. In this episode, we discuss how companies should approach security as their needs develop. Steve shares what he's observed at the larger companies he's worked for and how their needs differ from both startups and companies that are trying to scale up. We follow that up with a discussion about what every employee can do to help build secure systems and talk about some practices that will help in developing a security mindset, even for people who aren't trained in security.
Designing, manufacturing, installing, and maintaining the high-speed electronic computer, the largest and most complex computers ever built.
Thanks for joining us, Steve.
Thank you.
Right now you work at Databricks. For the people who don't know what that is and what the company does, I wonder if you could give us a primer and also maybe tell us a little bit what makes Databricks an exciting place to work in security for.
Yeah, sure thing. This is always a challenge because it kind of does a lot, and so I need to boil it down to a good catchphrase. But you can think of Databricks as a way of working with and visualizing your different data sources that you already have. So imagine you've got data in an S3 bucket. You can run Databricks' runtime, which is built on Apache Spark, that can plug into all these different data sources. And then from that, it gives you a way of using Python notebooks or Scala code and being able to do your data science and data engineering on top of that. So it's interesting from a security perspective because, the product has kind of gone from almost like an on-prem, deliverable software into a cloud service, like a software as a service. And we're in this state now where it's a hybrid model where there's a data plane and a control plane. The data plane is running on the customer side, so it's their responsibility. And then the control plane is like the Databricks operated, website service that will control the data plane. And so it's an interesting model where we don't have access to the underlying data, but we have the ability to run jobs and analysis on the customer's data on their behalf, and then, present the results in a nice unified interface. And it kind of creates some interesting settings and different complexity. I also think that the long-term trend will be more and more of moving into a software as a service model where more and more is handled by Databricks, the company, versus having things in your own account.
Yeah, got it. So the customer's data and the servers or wherever they store that has nothing to do with Databricks, though you access it for the analytics and for the accessibility of it?
I would say the customer would be running software in their own accounts. So imagine you have an AWS account and you would spin up some EC2 instances, and those would be running the Databricks runtime. And then the control plane would be able to interact with that and tell that runtime to go look over this table and return your results here. And then the UI that's presented to the user is a nice interface that lets you run like Python notebooks or whatever you want to do. There's a nice dashboard interface to build dashboards and provide a SQL interface. So from a security perspective, this creates a lot of questions about providing access control and customers bringing their own key material to encrypt that data and making sure that the control plane doesn't have access to your actually underlying data. So it's an interesting security model, and I think that it has some advantages and disadvantages.
So you've been with a number of companies working in security, previously at some rather mature companies and now at an earlier stage company. Could you take us briefly through some of the differences and how security matures as companies mature?
Sure. So just for a little background on myself, I had previously been at Facebook and Google, which are probably the two mature companies you're talking about, and then had also worked at some very small startups, and then now at Databricks, which is kind of a startup becoming a big company. And I think that some of the big differences are at more established companies. A lot of the security infrastructure and problems have not been solved, but somebody's addressed them in some form. Whereas, today a company like Databricks, we're kind of transitioning from the point where you may have had something that was like a stopgap solution or had not been addressed, and now we're building out some of the infrastructure that you would need in the future. So it's really looking at what it takes to go from a product that is been working and has customers, and maybe has some features that need to be improved, and figuring out what needs to be solved for like the next 10 years, and building out the infrastructure that you'd want to have in the future. And that's the kind of infrastructure that I, as an early employee or as an employee, was able to use at those big companies.
So, and at the small to medium company, you don't have the infrastructure, so you're just trying to. It's presumably a juggling act between trying to build that stuff up on the fly and dealing with existing issues, basically.
I think that's right. I think it's trying to look at where you have common problems that come up, and so, an example that in general would just be like web frameworks. Like, most companies today use some sort of web framework that will avoid common web app security issues. And that's the type of thing that solves a class of problems that if you don't have it in place, it'll get recreated by developers again and again, and not to their fault. Like the reason why you need these frameworks is to prevent people from making common mistakes. Another great example is cryptographic keys and crypto tools. Left to their own devices, people need to solve problems, and they will go Google, Stack Overflow or whatever forum post to figure out how to encrypt a blob of data or sign a blob of data. And there's no way to know that the thing you're looking at may be 10 years out of date or have a vulnerability or have a typo. And the solution to this is to build that infrastructure that gives people the safe options by default. So if it's a key management service that handles your keys for you, if it's a cryptographic library or cryptographic service, whatever it is, that just basically makes your internal developers' jobs easier and safer.
Gotcha. So you can say when things have been done in the way we set it up, we're probably okay, and then you can focus on the exceptions as things that maybe need a closer eye to security, rather than having to focus on everything and worry about everything if you get that set up appropriately.
Yeah, I think that if you see like a pattern of common mistakes happening again and again, you might sit back and say, you know what, it's about time that we provide a tool that does this for people so that they don't have to keep figuring it out for themselves and can do the right thing. And whether that's web app design, whether it's token generation, credential management, whatever it is, that you get to that point where you've observed it being a problem multiple times, and it's time to put something in place to make it safe.
And presumably sometimes you get to the point where that's going to be win-win, in the sense that that confusion is actually costing you at a certain point. People are taking longer to figure out how to do this stuff, even incorrectly. And so if you can provide that framework, it would help them quite a bit in just getting to a solution faster, as well as increasing security at the same time.
Yeah, I think so. And like a good example of that is something like access control list management. A lot of companies will have some sort of internal, whether it's user to service or service to service access control system. And, if you have to reinvent that every time, let's say you have two services talking to each other of how to, authorize access to one another, you're wasting a lot of time and having a lot of redundant code and probably not doing it right all the time, and also making it hard to maintain, hard to manage, hard to audit. So something like that, putting it into like either a centralized service or some sort of common library, does save developer cycles, and at the end of the day is making your system more secure and also just more understandable. That's really what it comes down to, is being able to answer questions about how does this thing work, and why do I think it's secure, and how do I know that the right people or systems are accessing what they're supposed to be accessing.
To go back to Databricks, we speak to a lot of Databricks sounds like it's pretty big right now, and there's there's lots of customers, and it's I think it has a multiple billions of dollars valuation, so it's not small anymore. We talk to a lot of smaller companies that start out that might end up in that situation, and often there's this question of we meet thoughtful people that want to think about security earlier on. But there's always seems to be a trade-off when you're starting to build something, because you need to validate that there's actually a market for it, or validate that the tech will do what you want it to do for customers. So, small question, right? But like, how do you think about companies that are starting out? How would you suggest they think about when it is time to think about security, in which kind of dimensions, but how much how much security and when? Go.
It's a good question, and I think that security people in general, at least myself in the past, erred on the side of, hey, this has to be secure. Security is really important. Your company will die if you don't have this in place. And the reality is that it's one of many different needs. And if you're starting out as a small company, the end of the day is you need a functional business to survive. Your company has to make money and profit to continue. And the security won't matter if you don't have customers and you're not able to serve those customers. So I see security as a support system for the product and the underlying business. You can build the most secure data storage, crypto, whatever. And if there's nobody using it, it doesn't matter. So I think that those early companies, the things I would try to do are to avoid creating problems in the future and making early decisions that come back to bite you. So there's, incremental things you can do that can put you in a good place. And so one of those would be, looking ahead and figuring out that, hey, if I'm going to sell to enterprise customers, they're going to have their own compliance checklist. What can I do today to make answering that easier? So I think one of the people you interviewed on the show, Dan Guido, has like a how to get SOC 2 from like a startup guide. I don't know, it might be attributing to the wrong person, but somebody out there is a good guide for the first thing you do is like use an SSO provider. Then all your logins are through one thing, and it's easy to account for like what your employees have access to. Simple things that most companies probably are doing today, but doing it consciously and then documenting it and then having those answers in the future where it's like, all right, how do you know that malicious source code isn't checked in? And you've got the process of like, here's a repo, here's a review process, here it is. And so, yeah, I think that would probably be my advice, is to look ahead to what you'll need to enable that sales process, to make sure you can answer the questions of how your system works and what you're doing. And, make sure that you make decisions today that will make that easier to convey to somebody. If you take shortcuts and they're like, yeah, we dumped this in a plain text table somewhere, and when somebody asks, you're like, have to explain that to them, anticipate that might be an issue. So that's probably a good frame to look at it, is how do you explain to somebody else what you did and why you did it? And that can kind of put in light of like, yeah, maybe we shouldn't take this shortcut where, the single developer has the root on their laptop and they can see all the data, whatever scenario you want to think of.
So when you talk about something like SOC 2, it's going to help you with some technical things. It's going to help you with some people things. The justification, I guess, at the end of the day is like, we won't be able to make a sale, a specific sale, unless we're able to get this through this checklist. Is SOC 2 going to help with a lot more than making the sale at the end of the day?
I think it's a good driver. Obviously with any sort of compliance regime, some parts of it are not going to be relevant to your underlying business. PCI compliance might be talking about, individual network configurations or firewalls, and you might be it's a completely like cloud model where the things it asks for don't make exact sense. I think that, if you're looking at it from like a startup where you may not have that first customer, I would just be anticipating it. Like, I wouldn't necessarily go through the effort of getting yourself compliant out of the box, but just say, we may have a customer in the next 3 months, 6 months who is going to ask for this. How do we address, what will we need to do to get there for them? And it doesn't have to happen at once, but you should at least know how long will it take? What documents do we need to produce? What's the steps that we would have to take to meet this? And, look at it as like a continuous process and not just a one-time thing where, all right, we did X, Y, and Z, and now we're good, we're secure, and we can sell to people. It's more of like, this is going to keep coming up. You're going to have different customers who are going to have different different checklists. They're going to have different things to ask for, and just be able to answer their questions. And then also, in terms of growth, just how are you going to be able to grow, the regions you're in, the number of employees working on this, how are you going to be able to do support? Things to think about early on, that so you don't make bad decisions. I think a lot of companies can get in the situation from the startup days where like, okay, everybody had root, everybody can read the database, everyone can go do anything they want in production. And that's hard to break that habit once you get a set of people who've been at the company and have their development process for years where they're like used to logging in and, deleting rows from a table. That's really hard to break over the long run, and especially as people get used to it. So kind of think about, let's not give everyone full access to start with. What can we do to make this a little more controlled, with the balance of like, you actually do need to develop and get stuff done. So, a good example would be having multiple environments to start with. Like that's something I think a lot of companies can do, is have a dev and staging and prod environment, or some sort of very realistic testbed environment, because it lets your engineers do what they need to do to build the product, debug the product, without having the gates open from the get-go. And I think my time at Google, I never was there at a time where it was kind of like wide open. It was always pretty well controlled, and they had like these tiers of environments by the time I was there. So that's kind of a good model in my mind of like, I never had access to customer data there, and I don't even know what the process was, because I never had to, because I was able to develop like fully without doing that. I mean, other people would need to go into production systems to debug things, but I never really had to.
Yeah, I guess that's ideal, right? That's the ideal case.
It can be liberating as an engineer, from the sense of like, I think the pressure of like being able to maybe accidentally break prod, people find it maybe thrilling, and people find being able to get things done quickly in the absence of like, I know this is right, I'm just going to put it out there, is nice. But at the same time, it's always sort of nice to say like, well, there's a backstop. Like someone might catch some things before, there might be tiers, there's other people watching, there's systems watching. In some sense, it lets you experiment a little more sometimes, I think, than being like, well, everything I'm going to push is going to like, it could ruin a customer's day. If I put this out there wrong, it's going to change the way you think. So it's sort of it's hard to say what's, what's better for just from like the individual developer side. Because I know some people get accustomed to that, like, it's going straight to prod kind of thing, but it's not clear that it's all that great.
I think having like good access control in place, where exactly like you said, that something you do is not going to accidentally wipe out a whole database, because you don't have the rights to it. You have to go through some process to get your job, or whatever you're talking about, the rights to do, whatever that destructive action is. And, I think this kind of speaks to something else, where security doesn't have to be antagonistic to regular engineering and development. There's a lot of things where it's aligned. So a good example is talking about these multiple environments, like having a non-sensitive environment to develop in where you don't have any customer data. That's actually great for stability, because I can test all my stuff in there. I can have like shadow traffic, whatever it is, where, this is not prod data. I'm not going to break anything. And that's good for development in general. And also the speed at which things can be released. So if you have a release cycle that is very long, it makes it harder to fix security issues. When you do have to do a security patch, it's like disruptive, because it's kind of out of the regular release cycle. So you get very short release cycles. That's great for an engineer who wants to get features out faster. And it's also great for security, because we can patch really quick and make sure that if there is a security issue, that, if it's a daily release or something, or hourly release, it'll go out with that. You don't need to do anything special.
This idea of security being antagonistic to engineers, and I guess especially in smaller companies, as they evolve to this, and they haven't thought about it before, I'm sure there's going to be, more often than not, a security person, the security person that comes in, or the little team that comes in, and it might feel like that, right? Because they're probably asking you to change things. How do you think about that? Like, how do you think about not necessarily splitting like that way when you have to bring in security as a later thing? And what would you given your experience, I'm sure you've experienced situations like that. What would you do to make that more smooth?
Yeah, it's a good question because I feel like a lot of companies that first person on will be more on the compliance side and more on the like kind of operation side. So, you know, a, several places I've been kind of have a split between the people working on the engineering side and product who actually are working on the security of the product or security features in the product versus security of the whole organization. And that might include like IT, operations of the infrastructure of like, how do you manage your cloud services accounts? Who's got access to that? Who's got access to the corporate SSO systems? And I think that often at companies, the original or early hires will be more on that ops side of who's setting up our firewalls, who's setting up our key management system, and that engineering side kind of comes on later. And I think that an early company, it may make sense to take existing engineers and kind of train them up to be more security representatives. So it's not necessarily you have to bring in a person who's going to run security for engineering work, but if you have kind of senior engineers who are familiar with the system and can think about it and have them be responsible for some of these things, I think that's okay to have that responsibility diffused among different engineering teams. And it really depends on the phase of the company. If you're a company with 10 engineers, it's like somebody's going to be responsible for it, and like there's not going to be 5 engineers working on security. So it really depends on the phase of the company and the market you're talking about. I mean, there's all different needs. If you're somebody who's in the working on health space, I know a startup with like 5 employees, and they're super security oriented because they're working with health data, and like that was the first thing out of the day. They can't operate their business unless they're HIPAA compliant, and they have to have that as a selling point for their product. So yeah, it really depends on the company size, the maturity, and the market itself.
But some companies do still end up in this, I think, situation where there's a security team that is viewed as antagonistic, almost like it's like, okay, great, the security guys are coming. We've got to get through this review so we can push our stuff to prod, and it's just going to be a headache. I don't think that's necessarily desirable, but do you have any ideas on how companies can avoid that kind of situation?
I think that can happen, especially if there's like a product release process where you have to have security sign off, and it's kind of like the last thing of the checkbox is like security, legal, privacy, and that needs to be early in the process. Like it just needs to be earlier in the process and be kind of a co-development process. So you don't want to just go at the end of the day and throw your product over the fence and say, check it out. A lot of people kind of just think there's like a magic, like pen test this button where you throw this finished product out the door and then somebody pen tests it and gives you back a couple things to fix. Like really that has to be earlier on. And so, if you're in that, I would say having design reviews early on to look for security issues. And again, this doesn't need to be somebody who's, a dedicated security person, just somebody thinking about it. Like just sit down and say, all right, what are we trying to protect against? What's new? What's changed? How do you address like, these 5 or 6 issues on new components, and really just somebody thinking about it. That's the main thing. Is it doesn't need to be like perfect, but just the act of sitting down, writing down what that threat model is, and thinking about, okay, what has actually changed here? What happens if somebody hits this with a ton of traffic, or how is authorization provided here? And a lot of times people are like, oh, it's not. We didn't think about that. So I think the earlier on the process you can do that. Now that statement is kind of baking in that there's actually like a design and a review process. So, early startups may not have a design process. Might be like, oh yeah, we got to do this thing. And then they build it the same day. So it really, I think this is kind of where it's a little bit more organic, and it's like companies need to find that balance where they are getting some sort of security oversight, but also not, burdening teams with too much pressure. And like I said, I think the best thing to do is view it as like co-creation, where you're not antagonizing the product team. You're there to actually get the product team out the door. And what are the things we need to think about, and basically bringing up issues that may happen. It's like, by the way, this new API has no rate limiting. And so if you open this up, you might get slammed. What happens if somebody does that? And then somebody might think, oh, okay, yeah, we got to put rate limiting on, or maybe we don't need to expose this, or maybe we need something else. So, things like that, just being the the person who thinks about it, because day to day, somebody building something is thinking about getting it to actually work. They're not thinking about all the ways that somebody out there might try to break it or that. And again, I think anybody can do this. Like, I don't think it's like some special skill. It's just like sitting down, drawing the picture of what it's supposed to look like, and then looking at the new things in the edges and saying, okay, what happens here? How is this? What's sent over this connection? How is this actually authorized? And it's a good exercise for, I think, anyone in engineering, not even necessarily engineers. This is something that like somebody from a non-technical background can do. It's like if you can talk about some of these things and just reason about it. You don't need to know how the code works underneath. You can just be able to look at a diagram and kind of understand like the basics of what's going on.
I think people underestimate how valuable the step of writing it down or typing it out actually is as well, because like a lot of people are like sort of like yeah I thought about it, like I don't think anybody could break this, right? Like this feels pretty good. But then a lot of times when you take even that step of just I'm going to write down what I think, like that forces you to just think about it that much harder and to get that much more intentional about what you're doing. But I think what really stands out is that your statement that like you don't have to hire a security person to do this. Like we've all seen systems break, and anybody that spent time engineering has seen systems and code break. So you have an understanding of the kind of things that can go wrong, and then it's just a matter of thinking like, could this happen to my system that I'm building now? And if you write that out, you're gonna do a better job than if you don't, basically. And in the long run, you can talk about security people, but if you don't have those resources, it doesn't mean that it's impossible to have any semblance of security or to build systems up in a secure way.
Yeah, I think just somebody sitting down and taking your design and explaining your own design back to you. Like for me, that's like the first thing I do is I read somebody's design and I say, okay, this is what I think this says, and then they can correct me if I'm wrong. And that's how I understand how it works. It's like, let me explain to you what you just told me and see if I got it right. And then at that point, it's, like you said, looking at just what's new, what's being protected, what are the new interfaces on whatever this is. If it's some storage system or an API or whatever we're talking about, user interface, and just asking the same questions. How is this validated? How is this authorized? How is this protected in transit? Like all the basics. And I think that a lot of people could do this. It's not like it's a skill that is impossible to learn or takes a whole career to learn. It's going through it a few times and kind of understanding like what to look for, and it doesn't need to be perfect. It's like the act of talking about it and thinking about it is really the benefit, and the output of this threat model, like really you're probably not going to look back at that. Like it's maybe there for later if you want to like explain to somebody how it works, so that's good to have, but it's the going through the act that is really the benefit.
Yeah, we say the same thing, I guess, with like formal methods a lot of the time. Is like it's great at the end of the day that you end up with this proof, but the magic, the journey is really what you're there for, and like spending the time with the code and having the tools be behind you to really double check that you're doing a solid job is where a lot of the value comes from. Like the tools make sure that you don't get lazy, but in the same way, just writing things down makes sure that you don't get lazy. And this really seems like something you can build into the culture of a company, right? Like at first you might have to remind people to do it, but I sort of think once people see the value in this, it seems like something you could build as a habit, basically, that would have positive effects across an organization, basically.
Yeah, I think the formal methods is a good example because it's the act of defining what it's supposed to do and trying to write out what you're trying to prove. And the actual proof is like, okay, great, it does what we think it does. But having to say, this is the behavior that we actually want it to have, that's the whole benefit of it. Because then you have to be very precise and, think about what you don't want it to do and all the positive and negative behaviors you want to have.
Yeah, in a way, you want the people who are going to be developing it to write that out. Because the farther those two things are, the less valuable it is, right?
What I would love to see as kind of a riffing on just hypotheticals is like have more of this tied together with the actual code, whether it's documentation that's side by side with the code or the specification of the code, and have more of this kind of done programmatically where, if I'm going to do a threat model, I can generate all the new stuff. It's like, okay, here's the new interface, here's the new calls. Let's go through them and, trace what's been tainted, what's been, is sanitized, and have that be more formalized. I mean, today that a lot of that is kind of manual and going through that. And like there do exist tools that do some of these things, but if you have a code like a development process that has the stuff checked into the repo. So that'd be a nice thing too, is having like the decisions alongside the actual implementation and saying, these are the threats we've looked at. Here's the understanding of it. If this changes, this should get changed too. And having that where it's not a huge manual burden to update, like that would be nice too, is having some of these things actually be auto-generated and just kind of like generate your punch list of things to review. That would be like a nice improvement on this, because like I said, today a lot of things are manual. I think they're getting better, but it's not like there's a magic tool to do this yet.
Sounds like a good product idea.
Yeah, and I think that, calling it a product is really important here, because I think one of the missing links in something like this is like, I think we can kind of imagine how that it might work, but user experience is going to be critical, and the amount of engineering that's going to go into making something like that, something that people just don't dislike using every single day. It's, I think, a massive effort that, like, honestly, a lot of formal methods people are just unqualified for. Like, how do we make this nice to use? How do we help people like enjoy using this and feeling like it's valuable and feeling like it's not in the way? I think there's a lot of sort of crossover research that needs to be done there, and that's like it very much needs to be a product. Like it can't be a research tool to get people to adopt it.
And that's true regardless of formal methods.
Yeah, just about threat modeling or high level modeling, right, or anything that comes out of research. Yeah.
Yeah, definitely the degenerate case is where you get this huge list of just completely irrelevant things to check through. And so I've definitely seen that with some of the tools out there. And it is a balance of making sure that you're not generating a bunch of noise that wastes people's time and doesn't really improve the underlying product. So, there's something to be said of having like some sense to this, and like what it's more of like an art, not a science, of knowing what to focus on and not getting too bogged down in some details which are not as relevant.
Yeah, on the other hand, we've seen all the pushback on things like UML. That's just like, this is just a consistent way to model things, and people are like, well, what does that mean? Like, it doesn't mean anything. It's just next to my code, and it's not. It doesn't apply to the code. So yeah, I think there is, when we talk about what's left in research, like the sweet spot in between checking something and providing some checkable value and tying things to code, and like, but not being too annoying, right? There's like the just right level of annoying. And I think, like linters feel like they've found this to some extent. Like most of the things they suggest, people are like, yeah, that's great. I can do that. Like it's going to make things better. But yeah, and type checkers, I think have sort of hit the same sweet spot, but for sort of slightly heavier weight specifications. I'm not sure that anybody's like just really nailed it on that yet.
Yeah. I like some of the stuff on like the, open API front too, where it's just a standard to specify what the API is and, potentially generate the actual interface. So whether it's like a, open API or like protobuf definitions, like some of those are nice too, because it gives you a clear picture of like, these are the APIs, like what's going on behind it's obviously not covered by that, but you can at least see the like, messages that could be sent between different services. And a lot of this I'm talking about is like very like infrastructure focused, like internal infrastructure of reviewing things. There's a whole different world of like, externally facing like web app features. And so, it really depends what you're building on and what you're trying to achieve.
Yeah, although things like Open API can have, generating nice docs that actually match what your API does is, it takes a lot of effort, and it's all too often sort of not done well. Like it's, we've all loaded up an API, and it turns out that like, yeah, the docs were two versions behind where we are now. So like you just have to search the GitHub issues to figure out what the API is now. It's companies struggle with this stuff every day, and it's like, it's a thing that needs to be done, but it's not the next feature. So how do we prioritize updating docs? How do we prioritize being secure when we actually need to do something new? I think that's a question that applies sort of across the board.
Yeah, I mean, it kind of reminds me of some things I've seen on this too. Is once you have those API specs that are very machine readable, you can do things like start fuzzing APIs. And I've seen some work on this and some implementations, but it doesn't seem like it's that widely used. And as a way of just like stress testing an API, you throw it up and then have something that will look at the fields it takes and then go through and throw a bunch of junk values at it and make sure that your back end is handling it as expected. And the other thing too is that versioning of things too, of just throwing like old versions of the same message and like just making sure that you can handle like unexpected fields and things like that. Like that, those are the type of things that you could easily automate with a nice protobuf definition or some API definition.
So, I mean, having seen lots of environments that presumably have APIs but aren't doing things like this, what's your insight into why this stuff just doesn't happen?
I think the examples I've seen of that are because of the complexity, and it's really like an integration test because you can't just test it on a binary like you would with like a fuzzing framework. It's like you're actually calling a service that's running, and that depends on other services. So it's like you can't just spin this up on one environment and test it in isolation. And that's kind of a challenge in testing in general of just, you have to spin up the whole environment to do like a realistic integration test. And having ways to, automatically mock out parts of it or have things where you can make that simpler, that's one of these things where it actually benefit developers too of, hey, we don't need to start the entire environment to test your one thing that you added. It's like you can maybe start some subsection of it and simulate the rest of the environment or have some like, replayed versions of data or whatever it is. So yeah, that, and also just like being able to drive, simulated traffic or recorded traffic at some of these things so that if you do make changes, you can replay realistic workloads at it and make sure that, it's working as expected. That I think are some improvements that could happen around this area.
Yeah, that matches up exactly, I think, with what with the episode we did with Dan Guido. This was like the main insight from blockchain smart contracts is like everything is testable and everything is reproducible in that space, and it lets you do a lot. Like anytime there's a bug, you have the exact same environment at your fingertips, and you can reproduce it. Like anybody can reproduce it right away, and that's really part of what's enabled that ecosystem, I think, to be as effective as it is. But that's testability is something, like you ask the question, do you have tests? And like sometimes the answer is no, but like how can you have tests is a very valid question in your system, right? Like does a developer have a way to actually write a test that applies at different levels of your system is a really good question to ask as you build things up. And I think this is another one of those things that if you try to build it up from the start as your system improves, you're going to have a much better time than if you try to come in once you have a full-fledged system and then tack it on, because you're just like it's work that just accumulates basically.
And this is somewhere I wish companies would share more about how they've designed their infrastructure, because if you're starting from scratch, like nobody knows how to do it. Like your startup and you're doing well, and in 5 years you may be like 5 times bigger, but you don't know how to design your system today to make it scale for 10x traffic in the future. And there's not as many like things to model. And I know Google's done a good job of starting to publish some things about like from their like SRE books on how to do this, but this is where I feel like industry could probably share more, because there's not really a lot of reason for a Facebook or Google or Stripe or whoever it is to share about how they design their infrastructure, because it's not competitive. It's like I could copy your infrastructure perfectly. It doesn't like give me an advantage over your established business. And so I wish that companies would share more about this, and especially on the security side of like security infrastructure, because I feel like people have reinvented the same building blocks over and over, and nobody kind of really shares them that much or talks about it. And if you go look at these companies, you're like, okay, everyone's got their own, crypto library or crypto tool, or they've like using the same tools, but we don't really like share that, hey, this is exactly what we're doing. This is how we do ACL management, or we're using these vendor products together. So that's where I feel like there could be more, discussion about just what we're doing on our infrastructure and how's it scaled up and how we do these things. And so, I think the security community focuses a lot on the offensive side, And, there's some things that are talking about the defensive side, but I haven't seen much on, how do you build security infrastructure? What works? What doesn't work? What are like success stories, failure stories? So that would be something I'd like to see.
Yeah. So security it's such a house of cards, right? Because as you're writing your threat model, right? Like good luck finding a threat model that doesn't say, like we're just not going to worry about like somebody loses their, Google authentication gets broken and anybody can log into anybody's Google account. Like, okay, like everybody in the world security has just been blown up because they can all like reset passwords through Gmail, right? Like, there's a lot more subtle cases where somebody else's security failings result in sort of cascading security failings. So sharing makes a lot of sense in this world, I guess is the point, because like everybody's threat model includes a number of other companies. And if we can kind of raise the bar across the security industry, it's gonna help everyone in some sense.
I think so. I mean, I think also just to learn from other people and not have to go through the same process of learning, of trial and error of what scaled and what doesn't. And I think that, one way that this gets transferred between companies is just people who have, moving between companies, engineers who are like, oh, Twitter does this, Facebook does this, and this is their build system. And so there is knowledge that is circulated that way. And so, I think that one lesson from that, it kind of helps to build teams that have backgrounds that are diverse from different companies, different industries, because I don't know, you get somebody from like the aeronautical industry and they may have like great ideas on reproducibility and testability because they're dealing with systems that planes will crash if they do it wrong. So, having people from different industries, different backgrounds is probably a big strength here, because you're going to learn that there's probably solutions out there that you're reinventing the wheel for that somebody already knows how to solve.
If you happen to hire them, right?
If you happen to hire them,
being
yeah.
on your team. And this idea of an open source mentality is what I'm hearing for security and infrastructure design. We'll probably open that up to even more people.
Yeah, and also open sourcing some of the things that companies have built internally. I mean, I think that the challenge with some of them is it's so tied into their bespoke infrastructure that you can't just lift a Facebook service and open source and have it be usable for anybody. So but not everyone is a Facebook or Google or one of these big companies, and there's probably a lot of companies that could benefit from having more open source things. And so like Google's Tink crypto library is one that I think is great, because that's just like, okay, you can use that as a crypto library. It's backed by a big company. It's pretty good model to look at of just doing the right things by default, and then you don't need to worry about your engineers using an insecure mode or insecure key size, or it kind of handles a lot of the key rotation for you. So things like that I think are great developments, because again, like Google sharing that doesn't hurt Google at all. It just benefits more people using it, and if you do use it, you avoid a lot of problems.
Great. We should forward this podcast to them after this.
Yeah.
Well, this has been a fun conversation. Steve, thanks for chatting with us today.
Thank you both. This has been a good conversation.
Agreed. All right. This is another episode of Building Better Systems. See you all next time.